Hi guys, so good morning. Sorry for the late upload of this recording. So for today, we will be discussing chapter 4, chemical reaction. Okay, so when we say chemical reaction, this involves reactants and products, no? So in a chemical reaction, we uses different letters, numbers, symbols. So in this case, when you see S, no, it means solid or nasa solid state yung reactant compound or atom. Kapag nakakita kayo ng L, it means liquid, of course. Kapag G means gas, no? Sometimes when water is involved, no, we put H2O above the arrow, meaning dinisolve natin yung reactant sa water, no? Sometimes yung magiging product niya, no, since na-dissolve yung reactant, we use is AQ. Pag nakakita kayo ng AQ, yung ibig sabihin yun ay aqueous, no? Meaning na-dissolve siya sa water. So in this chapter, we will not just discuss terminologies and how reactant and products were written. We will also discuss the mass relationship that is also known as stoichiometry. Guys, stoichiometry, more on computation po tayo dito. Kaya, please prepare your calculators, no? Kung face-to-face classes to, no need, hindi pinapayagan yung mga phone, no? Scientific calculators. But na, syempre, no, tayo ay online, you can use all the equipments no available sa inyo ngayon. So, marami ngayon na nadadownload na app na scientific calculator and also pwede rin kayong download ng app na periodic table since yung iba sa inyo malayo sa bilihan ng mga periodic table. But then I suggest na bumili na rin kayo or mag-print kayo ng yung ibang students ko before nagpe-print ng periodic tables, no? And then yun yung ginagamit nila. Ano pa? Ano pa i-aral natin in this chapter? Types of reaction. Okay? Heat gain and loss accompanying reduction or ito yung tinatawag nating redox reaction. Maybe some of you have encountered it on your senior high, no? Itong redox reaction, pero we will dwell on it or we'll dive on it deeper. Okay? So, combustion, no? Combustion is an example of a type of reaction. So, ito ay reaction through air, no? Ito ay burning in the air. So, may involvement lagi. Pag nakakabasa kayo ng combustion, may involvement lagi ng oxygen. And we have different types of combustion. Meron tayong partial combustion, complete combustion, which will be discussed in your laboratory. So the following chemical equation tells us that combustion of a propane gas, no, commonly seen sa mga LPG gas natin, gives carbon dioxide. Itong propane gas gives carbon dioxide, gas in gas form, and water. Ma'am, bakit yung water in gas form? Probably nag-evaporate na po yung water molecules natin. And also involves oxygen. But while it tells us what the reactant and products are, tandaan ninyo yung nasa left side, these are the reactant. So, enabled to produce the product, we must create, no, or check who are the reactant before natin ma-figure out kung sino yung product. So, some reactions are reversible, no? Pag nakakita kayo ng ganitong arrow, ibig sabihin reversible yon. Okay, pwedeng ibalik from product papuntang reactant at from reactant magiging product. So, according guys sa law of conservation of mass, dapat walang no matter cannot be created nor destroyed. So, kung ano lang yung present na atom dito sa ating reactant, yun lang din dapat yung present sa ating product. Hindi pwedeng bigla-bigla na lamang magkakaroon ng reactant or product. Okay, next tayo. So, how to balance a chemical equation. This is very important part, lalo sa general chemistry, na may knowledge kayo on how to balance your chemical equation. But why are we balancing chemical equation, guys? Balancing chemical equation is used to conform sa sinabi ko kaninang law, which is law of conservation of mass. Okay? Kung ilan ang number ng atom na nasa reactant, yun din dapat ang number ng atom na yon sa product. Okay? So, say for example, without balancing, no, kunyari wala pa tong 3. Kung bibilangin natin, no, before tayo mag-balance ng equation, no, bukod sa sinasabi dito sa ating slide at sa book, since ito ay galing sa Bettelheim ninyo, no, I do recommend na i-list nyo muna lahat ng atom na present sa isang side ng equation. So, for this, for the reactant side, no? For the reactant side, we have carbon, hydrogen, and oxygen. Check. Okay? Sa product side, dito sa product side, we have carbon, hydrogen, and also oxygen. Kung mapapansin niyo hindi pwede na magkaroon no, ng nitrogen dyan. Kasi wala namang nitrogen sa reactant. Okay, after listing all the atom present on each side of the equation, ano yung kasunod na gagawin? Guys, I want you to quantify, no? Quantify the number of atoms on each side. So, dito sa reactant side, how many carbon atom is present, no? It is denoted by the subscript number. Okay, so for this, ang subscript ng carbon is 3. Guys, for this one, later na yan. Sige, sige. How about hydrogen? Hydrogen is 8. How about oxygen? Oxygen is 2. On the other side, no, sa product side tayo, how many carbon atom is present? Guys, take note, when you see a coefficient, it means 3 moles of carbon dioxide, no? 3 moles of carbon dioxide. Ibig sabihin, may 3 molecule ng carbon dioxide. Yung mole does not mean molecule, ha? Mole is not equal to molecule. Magkaiba yun. Okay? Pero dito sa equation na ito, no, meron tayong 3 molecules ng compound na carbon dioxide. Yung moles and molecule, we'll discuss that later in stoichiometry kasi ginagamit yan sa conversion. But later na lang yun. Okay? Dito muna tayo sa balancing equation. Okay? So, ilang carbon atom? Guys, kapag wala kayong nakikitang subscript sa isang atom, ibig sabihin 1 yon. So, for this type, no, carbon, may 1 yan na subscript dito. Ma'am, anong role ng coefficient 3? Guys, you have to multiply your coefficient 3 to 1. Okay? So, kumbaga, nakaganito yan. 3 times, yan. So, kung i-distribute natin, no, magiging C3O6 yan. Okay, ganun mag-distribute ng coefficient. Okay? So, for carbon, how many carbon atom are there? No? Huwag mo natin pansinin yung kulay pula kasi yung kulay pula kakadagdag lang nun. Okay? For balancing yun. So, I want you first to list all the atoms present in both sides of the equation. So, carbon here is 1. Oxygen here is 2 plus 1 is 3. Hydrogen here is 2. So, as you can see, no, sa carbon pa lang, nauna nating nilist, no, 3 dito, 1 dito, hindi na balance yung equation. Okay? Yun yung unan yung step na gagawin. List all the atom from both sides of the equation, from the reactant and from the product. Next, what you are going to do is, look for an atom. Ito na tayo. Number 1, no? Look for an atom that is present only in one compound. Okay? So, dito, tingnan nyo, both side yon ha? Tingnan ninyo. Yung oxygen dito, present sa carbon dioxide, present sa water. If you're going to balance oxygen first, mahihirapan kayo. Kasi present siya in more than one compound. Which is si carbon dioxide, present yung oxygen, present din siya sa water. So, X na si oxygen. X na muna yung oxygen. Ito pa guys. Lagi niyong tatandaan na last nating binabalance ang mga atom na nag-iisa. Okay? Ito. Oxygen. No? Isang atom lang yan. Element by itself yan. Okay? Diatomic lang yan kaya dalawa. Pero element by itself yan. So, last na natin yan. Kasi guys, madali na lang mag-adjust kapag iisa. Tama ba? Say for example, 10 dito yung oxygen. Ano ilalagay mo sa oxygen dito? Lalagyan mo lang ng 5 without disturbing the propane. Naiintindihan? Naintindihan? So, ang una natin ibabalance si carbon. Okay? So, kung 3 si carbon dito, ulit nga, C3H8O2. Here, siya ay CHO. CI1, oxygen is 3, hydrogen is 2. So, kailangan natin gawing 3 si carbon. No? Paano natin gagawing 3 si carbon? We have to put, dahil ito ay 1, 3 dito, para times 3. So, ang nangyari doon, na-multiply din si oxygen by 3. So, dito, magiging ano na siya? Magiging 6 plus 1, no? 7. No? Balance na ba? Again, guys, dahil si oxygen dito ay nag-iisa lang, last natin siyang ibabalance. So, si hydrogen muna tayo. Dito, hydrogen is 8, sa kabila is 2. So, madali na lang, no? Paano natin gagawing 8 yung hydrogen, no? Multiply this by 4. So, yung ating hydrogen, ano na ang mangyayari sa hydrogen? 4 times 2, magiging 8. So, dito, magiging 8 na yung ating hydrogen. So, kung tapos na si carbon at si hydrogen, sino na next nating ibabalance? Si oxygen. Tandaan nyo guys, nagligay tayo ng 4 dito. So, 4 times 1 is 4. Dito, ilan si oxygen? 3 times 2 is 6. So, 4 plus 6, magiging 10. Dito sa kabila, paano natin gagawing 10 yung oxygen? So, madali na lang siya, no? Kasi hindi natin madidisturb to. Kaya laging sinasabi ko, lagi niyong ipapahuli ang element by itself, i-balance. Kasi mabilis na lang mag-adjust kung wala namang naapektuhan. So, dito, 5 ang ilalagay natin. So, balance na ba ang equation? Yes, balance na. So, dito sa pinakababa, yung balance na equation niya. Try nating i-check kung balance na nga talaga. Here, C is 3, hydrogen is 8, oxygen is 10. Dito sa kabila, carbon is 3, oxygen is 10, hydrogen is 8. So, balance na ang ating equation. Okay, ganun tayong mag-balance. So, meron tayong mga practice problems dito. Pwede nyo pag-practice ang sagutan. Pwede nyo pag-practice ang sagutan ngayon. Pwede nyo i-post to para ma-check. No? And then, i-post nyo lang yung video. Tapos, i-continue nyo kapag na-balance nyo na. Okay, so ito yung solution for the practice problem. Kindly check your work. Take note, no? Medyo maguguluhan kayo dito sa itong part na to. Guys, kasi dito nagkaroon ng odd, no? Nagkaroon ng odd number, no? Which is 13. Guys, kapag may odd number kayo, divide nyo lang siya sa 2. Okay? Divide nyo lang, halimbawa, sige, balance natin. Itong part lang na to. Baka kasi ma-confuse kayo. Okay, so, again, list muna natin. Ay, separate pala to, sorry. Itong C4H10 or yung butane, which is liquid, no? Plus oxygen, 4CO2, 5H2O. So, try muna natin yun dito sa kabila. Okay, dito. Yan, dito tayo. Okay, so i-list natin, no? Carbon, oxygen, hydrogen. Carbon, oxygen, hydrogen. So, i-list natin yung initial. I-list natin yung initial. Carbon here is 1. Oxygen here is 2 plus 1 is 3. Hydrogen here is 2. Carbon here is 6. Hydrogen is 12. Oxygen is 6 plus 2 is 8. Okay, so hindi siya balance. So, mag-start ulit tayo kay carbon. So, kung mapapansin ninyo, carbon here is 1. So, we should add 6. Sorry, palitan ko yung kulay. Let's add 6, no? 6. So, that means magiging 6 ito. Yung oxygen natin, magiging ano? 6 times 2, magiging 12. Tama ba? Magiging 12. Ay, sorry, 13, no? Plus 1, 13. Okay. So, next nating ibabalance is your hydrogen, no? Kasi nga, si oxygen dito ay element by itself. So, ilalast natin si oxygen. Si hydrogen muna. No? Si hydrogen dito ay 12. Dito sa kabila, siya ay 2. So, madali lang dagdagan natin ito ng 6. Tama? Para maging 12. Again, nagbago na naman si oxygen. So, ilan na si oxygen dito sa kabila? 6 times 2 is 12. Tama? 6 times 2 is 12. 6 times 1 is 6. So, ilan to? 18. Naging 18 yung ating oxygen dito sa kabila. So, dito naman sa kabila, ang ating oxygen is 8. So, paano natin gagawing 18? Paano natin gagawing 18? So, lalagyan natin dito ng 9. Guys, parang mali ako. I mean, tama yung ginawa nating pag-compute, na tama yung equation natin, pero yung equation na sinasabi kong may odd, hindi pala ito. No? Ito ko ay photosynthesis. So, kindly check na lang your work kung ganito din yung ginawa nyo. Okay, so isolve na lang din natin. And, so yan na guys yung balance nating equation. Kindly check your work, ha? Dito pala yung sinasabi ko, sorry. Butane plus oxygen, no? Magiging carbon dioxide plus water. So, again, i-balance natin by listing all the atoms on each side. Okay, so this one ay 4, dito ay 10, dito ay 2. Tama? Dito ay 1, dito ay 3, and then dito ay 2. Okay, so we balance the carbon first. So we add 4. Dahil 4 na si carbon dito, no, si oxygen natin will become, ilan to? 4 times 2 is 8, plus 1 is 9. Oxygen will become 9. Okay, how about hydrogen? Si hydrogen natin dito ay 10, dito sa kabila ay 2. So, let's add 5 para maging 10. Kaya lang, ito na guys. Ay, shucks, nawala. Ika lang ha. Nasa na tayo? 5. Okay, so ano na yung nangyari? Dito, 4 na yung carbon. Ilan na yung hydrogen? 10. So, balance na. Yung oxygen na lang, no? Oxygen dito ay 4 times 2 is 8 plus 5 times 1 is 5. Total of 13 oxygen. No? So, 13. So, kung mapapansin niyo guys, hindi nyo, since ang ating oxygen is diatomic, mahirap siyang gawing odd number. Okay? So, sige. Ano i-multiply nyo sa 2 para maging 13? Diba? Wala. Dahil siya ay diatomic, you have to divide it by 2. Okay? You have to divide. Ganyan kayo guys lagi kapag may odd. Okay? And diatomic yung molecule. Walang problema yan kung O lang yung nakalagay, element by itself. You just have to add 13. Tama? Pero dahil yun ay diatomic, meaning it cannot exist just by one element of oxygen, no? So, yung oxygen na yan, you have to divide by 2. Okay, para, kasi pag dinivide mo yun sa 2, meaning makakancel to. But then, guys, you can't have a fraction of an atom, no? Walang atom na 1.5. No, it's either may 1 atom ka or wala kang atom. Yun lang yun. Okay? So, ma'am, bakit kailangan mo i-divide sa 2? Enable for us to eliminate the fraction, you have to multiply all compound by 2 para makancel natin yung, so we can eliminate, no, so we can eliminate 2. So we have to multiply this by 2. Naiintindihan? Kasi, tingnan nyo ha, 2 times 13, 26 divided by 2 is still 13. Okay? Pero ano mag-iiba? Madadagdagan yung molecule nito. Magkakaroon lahat yan ng coefficient na 2. Then this one will remain 13. Magiging 8 CO2 plus 10 H2O. Now, we count the atom again just to check. Okay, CHO, CHO. Dito, ang ating carbon is 8. Ang ating hydrogen is 2 times 10, 20. Ang ating oxygen here is 26. Sa kabilang side, carbon is 4. Ay, sorry. Ito pala. Carbon is 8. Oxygen here is 16 plus 10, 26. Hydrogen here is 20. So, we finally arrive to its balance equation. Naintindihan? Very rare na magkaroon naman sa mga, usually siguro sa mga exam lumalabas lang may mga odd para pahirapan kayo. Pero rare magkaroon ng mga odd number. So, pag lumabas yung mga ganun, i-divide nyo agad siya sa 2. Okay, so that you can multiply all the compounds in both side by 2. Okay, except syempre dun sa gusto nyo tanggalin yung fraction. Kasi ang gusto natin dyan ma-eliminate lang yung 2 sa ilalim. Clear? So, baka lang maka-encounter kayo ng ganun. So, for number 1, solution is here. Kindly check your work kung tama. Okay. Okay. So, reaction between ions. So, ionic compounds are also called salts, no? It is consists of positive and negative ion. We have learned on chapter 2 that we have two types of bond. Do you still remember? We have ionic and covalent. When we say ionic, meron tayong positively charged atom and negatively charged atom, no? Like sodium chloride, no? They attract, nagpo-form sila ng table salts, no? So, ionic compounds, pag sinabi kong ionic atom, no? Sodium lang yon, chloride lang yon na may charge. Pag sinabi kong ionic compound, no? Ito yon, no? Positive and negatively charged molecule na nagsama at nag-form ng neutral compound. Yun yung ating mga salts. So, it is consist of both positive and negative ion. At ano nangyayari sa ionic natin? Nag-gain and lose ng electron. Do you still remember? Kasi kapag covalent bond, ano yung sinabi ko ng covalent? They are just sharing. And most of the organic compounds are formed through covalent bonding, which will be discussed in your finals na po. Okay, so what happened when we mix aqueous solution of two different ionic compounds? Guys, itong sinasabi dito, when a soluble ionic compound like sodium chloride or yung salt natin, kung mapapansin nyo, solid siya, dissolves in water, no? It dissociates two solvated ions. So, ibig sabihin, aqueous, no? Nakababad sa water yung ion. So, ito yung explanation yan. Mag-drawing lang ako saglit, ha? Pasensya na sa drawing. Dito, tubig yan, ha? Water. H2O. Okay? Naglagay ako ng sodium chloride or salt. Okay? Natunaw yung salt sa water. Nag-form sila ng sodium ions and chloride ions. Okay? Yung sodium and chloride ions na yan, no, patuloy lang yan lumulutang-lutang dyan sa water. Kasi nga, natunaw. Soluble, no? Soluble yung sodium chloride sa water. Try nyo sa bahay nyo. Asin nyo, tunawin nyo sa tubig. No, hindi nyo na makakitaan ng precipitate sa ilalim yan. Matutunaw lang yan. When we say precipitate, yun yung namumuo lang sa ilalim. Meaning, hindi soluble. Okay? Sa another glass, no, hindi na itong glass na to ha, itong drawing ko. Sa another glass, naglagay ako ng barium sulfate. Okay? Naglagay ako ng barium sulfate. Okay, barium sulfate. Palitan natin yung color, lagyan natin green. Naglagay ako ng barium sulfate. No? So, matutunaw yan sa water. Water soluble yan. Magiging barium sulfate. Okay, yun ay, guys, itong presentation na to, maraming molecule yan. No? Maraming molecule. Hindi ko na lang masulat lahat. Siyempre, maraming molecule yan kapag natutunaw. Okay, yung a powder of salt is composed of a lot of sodium chloride ion atom. Okay, kapag natunaw. So, dito, dalawa lang yung pinakita ko since yun lang yung kaya natin isulat. Okay, this one, yung may green is your glass 2. This red is your glass 1. Guys, I still have another glass. Okay, sorry, wala na pagsulatan na. Meron pa akong isang glass. Again, may water ulit yung glass ko na yan. May water ulit yan. Kaya lang, ang ginawa ko dyan, pinur ko yung red. Itong nasa glass na to na may water, pinur ko siya dito. So, anong nangyari dyan? Dahil ito yung dissolved sodium and chloride na, lulutang-lutang si sodium at si chloride dyan. Okay, hindi lang yun yung ginawa ko. Ewan ko ba kung bakit ko yung ginawa. Okay, hindi lang yun yung ginawa ko. Itong green, binuhos ko din dyan. So, dahil dissolved na si barium sulfate, may lumulutang-lutang dyan na barium at saka sulfate ion. Naiintindihan ba? Guys, ganito yan. Meron kasi tayong rule of solubility. Pero, ang sabi dito, what happens when we mix aqueous solution of two different ionic compounds in water? If two of the ions combine to form a water-insoluble compound, a precipitate form. If all ion combines are soluble, no change will be observed. Guys, kung lahat ng ion na yun magkakasama, hindi nyo maiiwasang mag-interact yung positive ng isa sa negative ng isa. What do I mean? Guys, si sodium at si chloride, dahil sila both soluble sa water, no, kahit ibalik nyo pa yan sa sodium chloride, matutunaw at matutunaw yan sa water. So, hindi yan magpo-form ng precipitate. Again, yung precipitate yun yung namumuo sa ilalim. Ang ibig sabihin nun, sila ay water insoluble. Okay, si barium sulfate, dahil parehas ni sodium chloride, kaya nilang ma-dissolve sa water, hindi sila magpo-form ng precipitate. Pero guys, positive attracts negative. Si barium dito, pwede yang ma-attract. Si barium dito, pwede yang ma-attract kay chloride. Magpo-form yan ng barium chloride, which is a form of salt kasi sila ay insoluble kay water. Naiintindihan? Si sodium sulfate, no, mag-interact din yan sa isa't isa, pero guys, sila ay soluble sa water. Okay, so, ano mangyari kay barium chloride? Guys, yung solution ninyo, palitan ko, teka lang ha, ilagay ko na sa glass 3 para hindi tayo maguluhan. Okay, may barium. Okay, yung solution ninyo ng barium chloride, magfo-form yan ng salt precipitate sa ilalim. Mamumuo yan sa ilalim. Nangyari sa sodium at sulfate, mananatili yang nagsisirculate dun sa inyong solvent. No? Pero magpo-form siya ng salt precipitate. Meaning, yung barium chloride na na-form is water insoluble. Now, the question is, ma'am, how would you know if it's insoluble or soluble? Kasi from that fact, from that idea, kung soluble siya or insoluble, ganun namin madodraw or masusulat yung aming equation. Like sodium chloride, naging sodium at chloride. Hindi sila pwedeng maging sodium chloride ulit. No? Kasi sila ay water soluble. Okay, hindi na pwede sila mag-mix uli. Kasi pag nag-mix sila, edi sodium chloride uli. Edi matutunan ulit sa water. Paulit-ulit lang. Okay? So, hindi na sila pwedeng ibalik. Sodium at chloride na lang. Tama? Tama? So, may rules ba tayo nun, ma'am? Guys, meron tayong rules. Ito yon, pero we'll discuss that later. Okay? So, dun yung malalaman if it will form insoluble salts or kung matutunaw lang ba sila. Magiging soluble lang ba sila. So, example, suppose we prepare this to aqueous solution. Meaning na aqueous solution, itong silver nitrate, natunaw yan sa water. So, nag-form siya ng silver and nitrate ions, no? Napacirculate lang sa water. Similar kay sodium chloride. So, if we mix the two solution, we have 4 ions present. Of this, meron tayong silver, we have chloride, we have nitrate, we have sodium. Yun yung nagsisirculate sa third glass natin. Tulad ng ginawa natin kanina. We have sodium, chloride, silver, tsaka nitrate. Okay? So, guys, dyan, ang tawag, no, gaya dun sa kanina natin, ang tawag dun sa namuo sa ilalim is our precipitate. Ma'am, anong tawag dun sa ionic na palutang-lutang lang sa tubig? Yung hindi nag-participate, no? Hindi nag-participate dun sa reaction para makapag-form ng precipitate. Ang tawag sa kanila ay spectator ion. Hindi sila nagpo-form ng precipitate. Okay, so in this case, no, pinagsama mo daw yon lahat sa glass 3. Ano ang mappo-form? Si silver chloride. Si silver chloride ay magpo-form ng precipitate salt sa ilalim. Yung ating spectator ion na hindi kasama sa pagbubuo ng precipitate ay si sodium at si nitrate. Therefore, si sodium at si nitrate ay mananatiling paikot-ikot lamang sa ating water solvent. Naintindihan, ang tawag dito sa mga ito ay spectator ion. Then this one is your precipitate. Kung mapapansin niyo may nakasulat na S, meaning siya ay solid. Okay? Therefore, guys, we sometimes simplify the equation and not adding, no? Hindi natin nilalagay sa equation yung mga spectator ions. Ang nilalagay lang natin yung nagkaroon ng reaction or yung nag-precipitate. Okay? Omitting all ions that do not precipitate. So, in this case, no, ang hindi nag-precipitate, ang nag-precipitate ay si silver chloride. Doon sa kanina, ang nag-precipitate natin ay si barium chloride. So, anong mangyari lang doon? Barium plus chloride, no, in aqueous to, aqueous, magpo-form ng barium chloride. Naintindihan? Solid. The simplified equation gaya nito, tinatawag natin yung net ionic equation. It only shows the ion that reacted. It only shows the ion that precipitated or participated in the reaction. So, ions that do not participate, ang tawag natin doon again ay ano? Spectator ion. So, how would we know? In general, ions in solution reacts with each other when one of the following can happen. So, ito lang yung mga isusulat ninyo as a net ionic equation. Kapag yung ions ng compound ay insoluble sa water, ito yung ginawa natin kanina. No? Ano nangyari? Nag-precipitate. Hindi natunaw sa tubig. Two ions react to form a gas that escape from the reaction. Okay? So, like this one. No, naging gas. Nag-form ng gas, no, and water. No, ito yung bicarbonate, no? Ito ay baking soda, tama ba ito? Bicarbonate ion. Tapos pag nilagyan mo ng water, bumubula. So nagkakaroon ng carbon dioxide. Ano pa? If an acid neutralizes the base and if one ion can oxidize another. Ito yung redox reaction. Okay? So, ito yung sinasabi ko guys na rules. Also, makikita at ito table 5.4. Makikicheck nga kung tama yung table. Pero, ito yung rule para malaman natin kung soluble or not soluble ang ating mga ions. So, all compounds containing lithium, sodium, potassium, rubidium, cesium, and ammonium are soluble. Tandaan nyo. Kaya yung kanina, di ba? Sodium chloride, no? May sodium tayo doon. So, sodium is soluble. Okay? Sodium is soluble. All nitrates and acetates are soluble. Tandaan nyo, all nitrates and acetates are soluble. Kaya yung silver nitrate natin, soluble. Kasi may nitrate. All common chloride, bromide, iodide, sulfates are soluble. Exceptions are. Okay, tandaan nyo, ito yung kanina natin, no? Barium sulfate, no? Silver chloride, lead sulfate, and lead chloride. Okay? Most carbonates, CO3, or phosphate, sulfides, and hydroxides are insoluble. Exceptions are lithium hydroxide, sodium hydroxide, potassium hydroxide, and ammonium hydroxide, which are soluble in water. Okay? So, next tayo, we have oxidation and reduction. Before we go to oxidation and reduction, I wanted you to master oxidation numbers. No, I think we still haven't discussed that on our previous chapter. So, for oxidation reduction, meron lang akong mnemonics na papatandaan dito. Okay, before we proceed on balancing electrons and not just the number of atoms but also the electrons and charges. Yun yung oxidation reduction reaction. So, when we say oxidation, it's the loss of electron. Guys, take note that ang electron charge is negative. Okay, so the more na nagiging positive, say for example, 0, plus 1, plus 2, plus 3, negative 1, negative 2, negative 3. Meron ako dito na copper, 0. Ito ay solid. Then we have copper plus 2. Guys, kung mapapansin ninyo, again, we must master oxidation first before you go to oxidation reduction. So, I'll send you additional videos na napanood ko dito sa YouTube that really helped me, no? Actually, I added yung kay Tyler DeWitt, kung familiar kayo sa kanya. Search niyo yung how to calculate oxidation number introduction first before we study oxidation reduction. So, meron kasi siyang ginawa dong table na para ma-memorize natin agad kung ano yung mga oxidation number ng mga commonly appearing monoatomic ions, polyatomic, and neutral compound. Okay, huwag kayong ma-confuse. Dito muna tayo sa oxidation at explain ko kung ano nangyayari sa oxidation number. Dito guys, kung mapapansin niyo, ang charge ng copper, no? Ang charge ng copper dito is 0. Okay? Pag ang charge ng copper or any metal or element by itself, no? Halimbawa, makakita lang kayo magnesium na metal, okay? Or zinc na solid, meaning metal. Ibig sabihin, 0 agad ang charge niyan. Okay? Kapag ganyan. So, dito, yung copper natin, from 0, no, nagkaroon daw ng reaction, naging plus 2. Kung hindi nyo aralin yung oxidation number, isipin nyo, 0 plus 0, tapos naging plus 2. Nag-increase, no? Case mali. Huwag nang kakalimutan, baliktad tayo dito. Dahil ang pinag-uusapan natin dito is electron. So, the more na nag-i-increase yung number, nagiging positive, nababawasan yung electron. So, dito, we can infer, we can conclude na from 0, naging positive 2. Ibig sabihin, nabawasan palalo yung negativity niya. Nabawasan palalo yung electron niya. So, anong nangyari dito? Nag-lose ng electron. So, this process is called oxidation. Naiintindihan? Naiintindihan? Ito naman, say for example, Fe plus 3, tapos naging Fe or iron, ferric to ferrous. No. Burahin ko ha. Ferric, ay shucks, sorry. Ferric to ferrous. Natatandaan ba yung nomenclature natin? Ferric to ferrous. No? So, from plus 3, bumaba siya ng plus 2. So, ano nangyari dito? Again, guys, medyo nadagdagan yung negativity niya. So, from plus 3, naging plus 2. Bumaba. Pag bumababa, ibig sabihin nun, nag-gain tayo ng electron. Naiintindihan yon? Naiintindihan? So, meron lang akong mnemonics dito, guys, na ang mnemonics ko for this one is Leora. Ito sa baba para mas mahaba. Leora and Geroa. Bahala na kayong gumawa ng mnemonics, pero ito kasi yung ginagamit ko lagi. Okay? So, loose electron, yun yung Le. Yung O, ibig sabihin, nagkaroon ng oxidation. No. Anong tawag sa kanya? Siya yung reducing agent. Okay, so say for example, dun sa ating example na Cu, naging, sorry. Ano ba charges ng zinc? Kalang ha. Positive 1 and positive 2. Positive 1. Okay. So, tama ba yung copper ko? Okay, positive 1 and positive 2. Okay, so, kung yung, pag nakakita kayo ng ganito guys, dalawang atom, tas may charges. Ang gusto kong gawin nyo is, para malaman nyo kung sino yung reducing agent at oxidizing agent, ihiwalay ninyo. So, for this one, yung zinc natin plus 2, naging ano? Zinc na plus 1. Yung copper natin na 0, naging copper na plus 1. Okay? So, dito, sino yung nag-lose ng electron? This one is plus 2, naging plus 1. This one is 0, naging plus 1. So, sabi ko sa inyo, the more na nagiging negative, the more na nagigain. The more na nagiging positive, the more na naglulos. Tandaan nyo na, baliktad tayo doon. Kasi baka isipin nyo na, ay, naging plus 2 galing sa 0. Okay, so from 0, naging plus 1. Sorry, naging plus 1. Ibig sabihin, nag-loss ng electron. Sino? Si copper. Ay, nabura. Saglit. Again, sorry, Leora Jeroa. So, ang gagawin, paghihiwalayin, plus 2, naging zinc, then copper, from 0, naging copper plus 2. So, again, meaning ng Leora natin is loose electron, oxidation ang nangyari. Then, kung sino yung nag-lose ng electron, siya yung reducing agent. Okay, for Jeroa, gain electron, no? Reduction, siya yung oxidizing agent. So, tatandaan ninyo, the more na nagiging positive, the more na nababawasan. So, dito, from 0, naging positive 2. So, alam natin na si copper yung ating nag-lose electron. From 0 to plus 2. So, check. So, ibig sabihin, ang nangyari kay copper ay nagkaroon ng oxidation. Siya yung na-oxidize. Okay, sino yung oxidizing agent natin? Yung nag-gain ng electron. Sino yung oxidize kay copper? Si zinc. Naintindihan? So, si zinc naman, from plus 2, naging 0, nag-gain siya ng electron. So, yon ay reduction ang nangyari. Okay? So, si zinc dito ay na-reduce. Sino yung nag-reduce kay zinc? Si copper. That's why si copper yung nag-loss, di ba? Siya yung reducing agent natin. And yung ating zinc, siya yung ating oxidizing agent. Kasi, inoxidize niya si copper. No? Kaya siya ay, yung ating nag-lose electron, siya yung process na dumaan sa oxidation. Naintindihan? Huwag maguguluhan doon, ha? Okay. So, before we move on, no? Before we move on to the actual process of oxidation reduction, this slide is from Tyler DeWitt, no? Isisend ko yung link from his video, no? I want you to memorize it, but then ilalagay ko na lang din dito, no, for the benefit ng mga hindi na makakapanood ng video niya. But still, I will put a link, no, sa video niya na lagi ko siyang pinapanood, and I've learned a lot from his discussion, no? So, wait, ito muna. Before I write all the notes from him, pag-aralan muna natin yung mga oxidation number. Guys, oxidation number is yung charge ng ating mga atoms. Okay? So, for magnesium, you can check the oxidation numbers in yung mga periodic table. No? Say, for example, Kay magnesium, si magnesium is positive 2 ang charge. Try to check it in your periodic table. Si chloride is negative 1. No? Siya ay halogen. Siya ay negative 1. So, dito, pag pinagsama at nagkaroon ng reaction ang magnesium at chloride, magiging magnesium chloride. Ma'am, anong mangyayari sa mga oxidation number? Okay, paano natin madadetermine kung magiging subscript? Guys, magkakross lang yan. Okay, dahil si magnesium ay positive 2, i-cross niya kay chloride yung positive 2. So, magiging chloride 2. Si chloride dito is negative 1, so you don't have to write 1. So, ang kanyang equation, pag nagmix ng magnesium at chloride, magiging magnesium chloride. Naiintindihan? Next one, next example. Sodium chloride, no? Sodium chloride. Si sodium ay positive 1, si chloride ay negative 1. So, kaya sodium chloride lang yan, no need to write sodium chloride. Another example, calcium hydroxide. Si calcium, ang charge yan is positive 2 kasi nasa group 2 metal siya. If you would check on your periodic table. Si hydroxide po, yan po ay in a compound, no? So, ang charge niyan, overall compound niyan, at overall charge niyan ay negative 1. Okay? So, if you would criss-cross, sorry. Ano ba, lagi ko napipindot yung erase. Okay, so if you criss-cross, ang magiging equation na natin dyan is calcium, no need to write 1, no? Ano nang i-write natin? Hydroxide. Ma'am, sa 2 lang, di ganito ba? Mali. Guys, dapat, dahil compound ang hydroxide, no? May close and open parenthesis and then yung 2. Naintindihan? So, ito yung sinasabi ko sa inyo na sinulat sinamary ni Tyler DeWitt sa video niya. Again, I will link Tyler DeWitt's video if you still wanted to watch other video of him. Sobrang helpful nun, guys. Please do so. Okay? So, ang sabi niya, an element by itself, no, is always 0. Say, for example, nakakita kayo na magnesium, no, na solid yan. Solid element by itself. No? Walang kahit anong charge. Automatic 0 po ang charge niyan. Okay, so calcium. Kanina yung calcium natin is positive 2. Ion yan, guys. Okay, pero pag nakakita lang kayo ng calcium, walang kahit anong charges, 0 po yan, automatic. Okay? Group 1A. Group 1A like potassium, sodium, lahat yan, always, no? Always, positive 1 ang charge. Group 2A like calcium, barium, always, magnesium, positive 2. Halogens, like yung Brinkelhoff na pinatatandaan ko sa inyo, chloride, fluoride, iodide, no? Sila yung mga halogens natin. Sila ay usually negative 1. Usually, negative 1. Pero, kapag kasama nila yung oxygen, positive, nagiging positive 1 sila with oxygen. Say, for example, ano ba example? Say, for example, guys, hypochlorite. Hypochlorite, no? Ang chemical formula ng hypochlorite is ClO. ClO. Ang charge nito as a compound is negative. Bilang kabuuan. Guys, actually, kung hindi nyo nakikita kung ano yung charge niya as a compound, pwede nyo siyang i-compute just by looking dito sa sinamary nga ni Tyler DeWitt. So, for chloride, sabi dito, siya ay example ng halogen, di ba? So, siya dapat ay negative 1. Say, for example, sa sodium chloride, di ba? Positive 1 si sodium, si chloride ay negative 1. But in this case, dahil kasama niya si oxygen, no, itong hypochlorite, si oxygen kasi is always, no, priority yan, negative 2 yan lagi. Okay, ang charge ni oxygen is negative 2 lagi. Si chloride, dito, dapat negative 1. Pero dahil kasama niya si oxygen, magiging positive 1 siya. Guys, to compute for the overall charge, dito, no, i-add lang natin. Chloride, Sodium is 1 plus negative 1. Ang overall charge niya, compound charge is 0. For this one, no, sa hypochlorite natin, plus 1 plus negative 2 is equal to negative 1. Kaya lagi nga makikita niyo yung hypochlorite would always have a charge of negative. No? Minsan, negative lang, it denotes negative 1. Okay? Naintindihan yung halogen. Usually, ang halogen natin or negative 1 is negative 1. No? Lahat ng halogen. Maliban na lang kung kasama niya as a compound si oxygen. Clear? For the monoatomic ion, mga monoatomic ion like sodium na may charge, yung ionic charge niya, syempre, yung charge niya. So, for sodium, plus 1. For magnesium na ion, ha, plus 2. No? Kung ano yung charge niya, yun yung charge niya. Yun yung charge na i-compute natin for it. Okay? Next one is hydrogen. Guys, si hydrogen may dalawang charge, positive 1 and negative 1. Kapag kasama niya ay non-metal, positive 1. Pag kasama niya ay metal, no, kasi ang kanyang charge is negative 1. Next, oxygen. Oxygen, usually siya ay negative 2. Okay? So, magiging negative 1 lang siya kapag kapag yung nasa peroxide. Ano yung peroxide? Gusto yung agua oxinada. Okay? Yung nabibiling agua oxinada. Yung nalagay sa sugat, no, H2O to. So, dito, negative 1 ang kanyang charge. Pero usually, negative 2 po ang ating oxygen. Okay, for fluoride, tandaan nyo, si fluoride, always negative 1. Okay, so, okay, ganong mag-compute ng oxidation number. So, sana, tandaan nyo ito, i-memorize nyo by heart, kasi dito, natin malalaman, mako-compute yung oxidation reduction. Ganito mag-balance. Okay? Okay, so, example, if we put a piece of zinc metal in a beaker containing a solution of copper sulfate, some of the zinc metal dissolve, some of the copper ions deposit on the zinc metal. So, the blue color of copper ion gradually disappears. So, in this oxidation reduction reaction, the zinc metal I think ito yung computation ko a while ago, no? Si zinc, no, dahil siya element by itself, ang charge niya ay 0, naging positive 2. So, ano yun? Decrease or increase? Decrease or increase? Nag-lose or nag-gain? Guys, mas naging positive siya. So, it loses electron. Therefore, yung ating mnemonics na Leora. Tama? Lose electron. Ano nangyari? Oxidation. Therefore, siya ay na-oxidize. Si zinc ay na-oxidize. Okay, anong tawag kay zinc? Reducing agent. Clear? Now, si copper naman, from positive 2, naging 0. Ibig sabihin, mas naging negative siya. Tama? Gaya nga ng sinabi ko, ganito yung para mabilis siyang tandaan. No? From 2, naging pababa, no? 0. So, siya ay nag-gain electron. Ano yung mnemonics natin? Zeroa. So, gain electron, ano nangyari sa kanya? Reduction. Therefore, si copper ay na-reduce. Sino ang nag-reduce? Yung reducing agent natin na zinc. No? So, anong tawag kay copper? Siya yung oxidizing agent. Naiintindihan? Sana malinaw yun, ha? So, ang oxidation reduction, since wala kayong analytical chemistry, din kasi dinidiscuss na ang one example kung saan nangyaring oxidation reduction is yung sa mga batteries natin. Okay, so ganito yung nangyayari sa ating mga batteries. May mga panels tayo doon sa loob, no? And mayroon tayong mga electrode doon kung saan nagkakaroon ng reduction, oxidation, reaction, no? Para mag-produce ng electricity, no? Yung difference ng mga metal kung saan sila nakasubmerge, gaya nito, yun yung nagpo-produce ng movement ng electron. Therefore, nagkokosyon ng, nag-give yun ng electricity. Okay? Okay. So, there are 5 important types of redox reaction. So, kailan na-apply ang ating redox reaction? Guys, Please solve the redox reaction at the end of the chapter sa mga Bettelheim book nyo. Please practice solving them. Also, please watch the video that I am about to send you, yung kay Tyler DeWitt, because sobrang helpful nun, guys, no? Doon ako natuto ng mga, doon ako, pag nakakalimutan ko yung mga bagay-bagay, doon ako nanonood. So, 5 important types of redox reaction. We have combustion, respiration, rusting, bleaching, and battery. So, for combustion, I guess I have discussed this a while ago. It means burning in air. So, my compound na involved, of course, air is oxygen. So, the product of complete combustion of carbon compounds are carbon dioxide and water, no? And respiration naman, no? So, it's the process by which living organism uses oxygen to oxidize carbon-containing compounds to produce carbon dioxide, yung ina-exhale natin, and water. So, the importance of this reaction is not the carbon dioxide produced, but the energy released. No? So, for rusting naman, no, ito yung nangangalawang yung mga bakal natin, ano nangyayari doon, na-oxidize kasi yun, guys, no? Dahil exposed siya sa oxygen, yung ating mga iron, ano nangyayari? Yung oxygen pwedeng maka-oxidize ng iron. No? At ano nangyayari doon? Bumababa yung oxidation number ng ating iron. Okay? So, for bleaching, kung mapapansin niyo guys dito, teka lang, before tayo mag-move sa bleaching, no? Ang iron dito, kahit may 4 pa yan, no? Kahit may 4 pa yan dito, element by itself pa din yan. Since wala siyang charge at siya ay solid. Metal. So, ang charge niyan is 0. So, from 0, ano nangyari? Paano namin malalaman yung charge ng iron dito? Guys, ito yun, no? Yung tinuro ko sa inyo kanina. Fe2O3. No, huwag niyo muna isama yung coefficient. So, di ba nag-criss-cross yan? Tatandaan ba? Okay, so ano mangyayari? Ito ay, ang charge nito is positive 3. Oxygen will always be, ano yung nasa rule natin kanina? Negative 2. Kaya nung nag-criss-cross, 2 yun nandito. Naiintindihan? So, ano yung charge ni iron? Positive 3. So, from 0, naging positive 3 siya. So, ano yan? Nag-gain, nag-lose. Guys, nag-lose ng electron. Mnemonics for lose electron, oxidation ang nangyari. Na-oxidize yung iron. Sino nag-oxidize? Yung oxygen. Okay? Sino nag-reduce kay oxygen? Sino nag-reduce kay oxygen? Si iron. Naiintindihan? Naiintindihan? Ganon siyang i-compute. Minsan kasi may mga compound na nawawala. Nawawala yung charge. Say, for example, HClO. No, pag may ganyan, tapos, alam natin na si oxygen is always negative 2. Si hydrogen is always positive 1 with non-metal. And chloride is non-metal. Tama? So, ano yung charge ni chloride? No, negative 1. Tama ba? Anyway, so bleaching. Bleaching, the oxidation of colored compounds to products which are colorless. So, oxidation yung nangyayari doon. Battery. So, ang nangyayari kasi sa batteries is both reduction and oxidation. Okay? Oxidation reduction reaction ang nangyayari sa batteries. Okay? So, formula weight. Dito tayo, malapit na sa stoichiometry. No? Guys, may dalawa tayong type na sinasabi. Kung babasahan niyo yung Bettelheim book ninyo, may mababasa kayo doon na formula weight and molecular weight. So, ginagamit ang molecular weight at formula weight interchangeably. Okay? So, weight is the sum of the atomic weights in atomic mass unit of all atoms in the compound's formula. So, say for example, no, ang ating sodium chloride, merong, ang sodium natin na ilan ang mass. Guys, kung titingnan ninyo, ang mass ng ating sodium is 23. No, atomic mass unit. At ang chloride is 35.5, no, i-add natin yan kung isang compound yan. Ang mangyayari is magiging 58.5. Okay? So, 58.5 yung atomic mass unit ng total ng atom na ito. Okay? So, ganun din sa iba. No? I-add nyo lang yung grams niya, no, sa from the periodic table. Okay? Sometimes, no, gram per mole, yung ating molecular weight. Okay, molecular weight. Ang unit ay gram per mole. So, dito, 58.5 gram per mole. No? Ganun yung, mas okay na ganun yung gamitin. Okay, so formula weight can be used for both ionic and molecular compound, no? While molecular weight should be used only for molecular compounds. Tandaan niyo yung pinagkaiba nila. Okay? So, mole. Ano yung mole, guys? Again, may isasend akong video din ng explanation ni Tyler Gill. Sobrang ganda ng explanation niya. No? Gusto ko lang padaliin din kasi yung pag-understanding nyo. Gaya ng pag-understand ko. Kasi I think mas malaki yung matutulong kapag napanood nyo yun and nabasa nyo yung book. So, what is mole? Mole is the amount of substance that contains as many atoms, molecules, or ions as are in exactly 12 grams of carbon. Okay? And a mole, whether it is a mole of iron atoms, a mole of methane molecules, or a mole of sodium ions, always contains the same number of formula units. So, parang ang mole, guys, is the dozen. Dozen. 1 dozen is equal to 12. Tama, 12 items of something. 1 dozen of egg is 12 eggs. So, 1 mole is equivalent to the number, which is Avogadro's number. Avogadro's number is 6.02 or minsan 6.022 times 10 raised to 23 units per mole. So, ito yung number ng atom na nasa isang mole. So, say for example, nagsabi ako ng 1 mole of carbon. 1 mole of carbon is equivalent to 6.022 times 10 raised to 23 atoms. Okay, hindi ko nabibilangin isa-isa yung 6.0221419 times 10 raised to 23 atoms. No? Kasi kung babanggitin ko yan, lahat ng number na yan, kung ilang atoms yung laman ng isang mole, no, abutin ako ng kailan pa. So, 1 mole na lang ang kadalasan nating sinasabi. Ano pang good thing sa 1 mole? Ano pang good thing sa mole? No? Guys, 1 mole is determined, no, experimentally, nandun sa periodic table ninyo, kung ilan yung weight nila. So, alam natin na 1 mole of carbon, ang weight nun ay 12 grams. Ibig sabihin, ang weight nitong 6.022 times 10 raised to 23 atoms, kasi sobrang dami niyan, no? Alam nga naman timbang natin isa-isa yan. Alam na natin na itong number ng atom na to, ng carbon, will always equate to 12 grams. So, masasabi natin na 1 mole of carbon is equal to 12 grams. Okay, no need to state na ang 6.02 times 10 raised to 23 ay 12 grams. Alam nga namang isa-isahin mo every time. So, kumbaga, shortcut yung 6.02 times 10 raised to 23 carbon atoms para mabilis bangitin into 1 mole. Naintindihan? Again, a mole is not the same as a molecule. Ha? Magkaiba yan. Okay, so a mole, whether it is a mole of iron, a mole of methane, a mole of sodium, will always contain the same number of formula units. Okay, so saan namin makikita yung weight niyan? Guys, check your periodic table. What about a molar mass? Guys, a molar mass is also your molecular weight, formula weight. It is denoted by gram per mole. Okay, so say for example, what is the molar mass? What is the molar mass of your glucose? Denoted as C6H12O6. So, iisa-isahin natin yan, guys. Carbon, ang mass ng carbon is 12. Tama, kada isang mole. And dahil 6 yung number ng carbon natin, times 6. Si hydrogen, ang mass niyan is 1 grams. Dahil ang ating hydrogen is 12 times 12. Okay? Si oxygen, ang mass niyan is 16 grams. Dahil si oxygen dito ay 6, imumultiply natin. Okay? Kuha lang calcu. So, 12 times 6 is 72. Okay? Then, 12 grams. Then, 16 times 6 is 96 grams. So, we will add them up. So, 96 plus 12 plus 72 is 180 grams. Naintindihan? So, ang molar mass nito is 180 grams per mole. 180 grams per mole. Okay? Kasi ito yung 6 mole. 12 mole. 6 mole. Okay? So, 180 gram per mole. Ganon din kay urea, denoted as NH2, 2 carbon, carbon and oxygen. So, sige nga, compute natin yung for urea. Just another example, no? Nitrogen is, ilan ba ang nitrogen? 14. Guys, 14 grams ang nitrogen. Hydrogen is 1 gram. Carbon is 12 grams. Oxygen is 16 grams. So, times ilang molecule ang nitrogen times 1. Hydrogen, distribute muna natin yung 2, no? So, ilang nitrogen? 2. Ilang hydrogen? 4. Ilang carbon? 1. Ilang oxygen? 16. 1. Okay? So, 14 times 2 is 28. 4, 12, 16. So, let's add them up. No, 16 plus 12 plus 4 plus 28 is 60 grams. Okay? So, meron tayong 60 gram per mole. Okay? Yun yung tinatawag nating molar mass. Okay, next tayo. So, we use molar mass to convert from grams to moles and from moles to grams. So, calculate the number of mole of water in 36 gram of water. So, paano yun? Guys, I hope by now marunong kayo ng factor label method. Yun yung ginagamit natin for conversion. Okay, so sabi dito, calculate the number of mole of water in 36 grams of water. So, paano yun? Dahil ang given ay 36 gram of water, 36 gram of H2O, multiplied by, since gumagamit tayo ng molar mass, anong unit ng molar mass? Anong unit ng molar mass? Gram per mole. So, alam natin na ang molar mass ng ating water, H2O, ay ano? Ito ay 16 times H2, 1 times 2, 16 times 1, 2 plus 16 is 18 grams. Gram per mole. Alam natin, no, na 18 gram per mole ang molar mass ng water. So, dito, guys, tandaan nyo sa factor label ha, lagi nating nilalagay yung gusto nating i-cancel sa ilalim. Ano yung gusto nating i-cancel dito? Guys, yung grams of H2O. And dahil alam natin na for every 1 mole of water, merong 18 grams, yung grams ang ilalagay natin sa ilalim. Okay, and then 1 mole sa ibabaw. So, cancel na lang tayo. Cancel. Dahil ang tinatanong kasi is mole of water. Yun yung hindi natin ika-cancel. Kaya siya nasa itaas. So, 36 divided by 18. Ilang mole daw ng water ang meron sa 36 gram of water? So, the answer is 2 moles of water. Okay, yun yung isa sa stoichiometry na tayo. Next, grams to mole naman. So, calculate the number of moles of sodium ions in 5.63 gram of sodium sulfate. So, guys, ito medyo complicated. If-forward ko ito sa mas simple na computation. Meron ba? Wala kasing space. Pasensya na. Okay, so, ang hirap mag-solve. Wala palang space, no? So, for a while, add lang ako ng extra space, ha? Para makapag-compute tayo. Ay. Insert. Hindi ako makapag-insert. Anyway, paano ba? Ayun, blank screen. Teka lang. Anong sabi doon? Ay, tapos nakalimutan, no? Sorry. Sabi dito ay, ilan daw calculate the number of moles of sodium ions in 5.63 sodium sulfate. Okay, so dito na nga lang. So, dahil ang given is 5.63 sodium sulfate, no? 5.63 sodium sulfate. Calculate the number of moles. Ilan daw yung number of moles ng sodium ito kapag yung sodium sulfate mo ay 5.63 grams. So, ang hinahanap dyan is mole of sodium. Guys, hindi pwede nating sabihin lang na i-multiply lang tulad nung kanina kasi ang given na may grams is sodium sulfate. Kumbaga sa compound na sodium sulfate, ilan daw dyan yung moles ng sodium. At hindi lang yon ang binigay na details. May 5.63 grams ako na sodium sulfate. Ilan dyan yung moles ng sodium ion. So, first we have to compute the formula weight. Hanapin nyo na lahat ng pwede nyo madagdag na pang-convert. So, formula weight or yung molar mass, hanapin natin kay sodium sulfate, no? So, ang formula weight natin dyan, as computed here, tulad nung ginawa natin kanina yung nag-add, is 142.1 atomic mass unit or gram per mole. Gram per mole, yan. Okay? So, dahil meron tayo na 5.63 grams of sodium sulfate, no, compute na natin yon by factor label method. Okay, so dito, no, meron tayong given na 5.63 gram of sodium sulfate. So, para i-convert natin itong gram sa mole, gamitin natin yung gram per mole natin na unit computed from the molar mass of sodium sulfate. So, for every 1 mole of sodium sulfate, ilan ang grams? 142. 142.1. Ma'am, bakit hindi sa taas nilagay? Di ba, ma'am, gram per mole? Di ba ganito yun, ma'am? Ma'am, bakit nasa taas yung gram, nasa baba yung mole? Tapos dito sa computation, nasa baba na yung gram, nasa taas yung mole. Guys, dito, no, kung ano yung gusto natin i-cancel at gusto nating hanapin, yung gusto nating i-cancel, lagay sa ilalim. Yung gusto nating hanapin, which is mole, lagay natin sa taas. Naiintindihan? So, we add 142.1 gram sodium sulfate. Cancel kasi natin yung grams of sodium sulfate. Now, we have 0.0396 mole ni sodium sulfate. So, alam natin na sa 5.63 gram na sodium sulfate, merong 0.0396 mole ng sodium sulfate. Knowing that, i-convert na natin. Nasagot na ba? Hindi pa. Ano bang tinatanong? Number of moles ni sodium. Hindi pa nasasagot. Yung number of mole ni sodium, kukunin natin dito sa mole ng sodium sulfate. Ma'am, paano yun? Okay? Dito sa sodium sulfate, ilan ang molecule ni sodium? 2. Ilan ang molecule? Okay, dahil gusto nating hanapin si sodium lang yung nagmamatter. Okay, ilan yung molecule ni sulfate? Isa. Pero hindi natin ilalagay yon kasi ang tinatanong dito is mole ni sodium. So, paano gawin yun? For every 1 mole of sodium sulfate, may ilang mole ng sodium? May 2. Okay, so ma'am, bakit nilagay natin yung sodium sa taas? But yung sodium sulfate kasi nga, guys, ang gusto natin i-cancel na unit, ay mole of sodium sulfate. Naintindihan? Ang gusto nating hanapin is 2 mole of sodium. Therefore, computing for this, mag-arrive tayo sa 0.0792 moles of sodium. Clear? Clear? So, a tablet, next problem. A tablet of aspirin, C9H8O4, contains 0.360 gram of aspirin. How many molecules of aspirin are present? First, find how many mole of aspirin are in 0.360. Dahil given ang 0.360, ano yung next na gagawin natin? Look for the molar mass of C9H8O4. Okay, so arriving on the molar mass, tandaan nyo, molar mass yung ginagamit na pang-convert. Ano yung unit nito? Gram per mole. So, ito na naman, guys. Ang given is 360. Kailangan natin i-convert itong gram na to sa mole ng aspirin. So, to convert, ilalagay natin yung gram sa ilalim kasi yun yung gusto natin i-cancel at gusto natin i-convert yung aspirin sa mole, hindi grams. So, arriving at the mole, ano ba yan? Arriving at the mole of aspirin, meron tayong 0.002 mole of aspirin. So, each aspirin daw contains 6.02 times 10 raised to 23. Ano to? Ito yung Avogadro's number. Ano ba yung tinatanong? How many molecules? No, molecules. Iba yun sa mole. So, kailangan mo daw i-convert itong 0.002 mole of aspirin into molecules. Ano alam natin na data kanina? For every 1 mole of any atom, meron tayong 6.02 times 10 raised to 23. Tama? Molecules. For every mole. So, pwede natin itong gamitin para makompute yung molecules. Tama? So, from 0.00200 mole times 6.02 times 10 raised to 23 molecules per 1 mole. No, na kahit anong atom yon, the answer would be 1.20 times 10 raised to 21 molecules. Kaya sa mga naguguluhan kung paano dinedeploy itong factor label method, ganito lang yan. Ganito yung simplest explanation. For every 1 liter, meron tayong 1,000 ml. Ang tinatanong ko, say for example, is ilang ml? Ilang ml meron sa, ilang ml meron sa 3.64 liter? Is equivalent to ilang ml? Okay? So, dahil ang hinahanap natin dyan is ml. Okay? At meron tayong given na 3.64. Ganito lang guys nag-work yung factor label. Okay? Ano yung gusto natin i-cancel? Liter. Kasi ang hinahanap natin ay milliliter. Okay? So, for every 1 liter, ilalagay natin sa taas yun. Ay, sorry, baliktad. For every 1 liter, ilalagay natin sa baba yan. Kasi yan yung gusto nating ma-cancel. Kasi, liter divided by liter. 0. Para sinabi na 2 divided by, 1, 2 divided by 2. 1. So, liter divided by liter. Maka-cancel yun. Okay? So, nilalagay natin sa taas, 1,000 ml. Kasi for every 1 liter, meron tayong 1,000 ml. So, anong sagot? So, anong sagot, guys? 3.64 times 1,000. The answer is 3,640. Sino na? Cancel liter. Anong tirang unit? Si ml. So, for every 3.64 liter, meron tayong 3,640 ml. Guys, binigay ko lang itong example ng metrics para maintindihan nyo kung paano nag-work yung factor label. Guys, ganun lang din. But instead of liter or yung common natin na nalalaman like centimeters, liters, pounds, feet, ang ginagamit natin dito is mole, gram, molecules, ano pa? Ayun, pwedeng gamitin nila kilogram, di ba? I-convert na lang natin sa grams. So, depende yan kung ano yung given. So, yung stoichiometry is the study of mass relationship in chemical reaction. So, following is an overview of the types of calculation we study for the conversion of reactants and product. So, meron tayong mga problems like this one. Mas malala siya kaysa sa mga problems na discuss natin a while ago. Kaya I do recommend na pag-practicean yung isolve yung mga nasa likod ng Bettelheim book ninyo. Yung nasa parang chapter review. So, in this problem, how many grams of nitrogen are required to produce 7.50 grams of ammonia given the following balance equation? O, ganito yung mga problem for stoic. Ilang grams daw ni nitrogen are required to produce 750 grams of ammonia. Okay, so ang tanong dito, ilang grams daw nito ang kailangan to produce 750 grams ng product na ammonia. First, find how many moles of ammonia are in 7.50 grams of ammonia. Okay, so meaning, i-convert lang natin, guys. Gaya ng ginawa natin kanina. So, dahil alam natin, na ang molar mass, mole per gram, ang molar mass ni ammonia is 17 gram per mole. 17 gram per mole. No? Or para hindi kayo maguluhan, 17 gram over mole. No? Pwede natin siyang gamitin for conversion. So, dahil given si 750 gram of ammonia, we have to convert that into mole para hindi tayo mahirapang mag-compute. Okay? Yun yung kaunahang gagawin. So, for every 1 mole, merong ilang grams? 17 grams. Sana na nasusundan na by now. So, bakit ma'am nilagay sa ilalim nito yung grams? Kasi we have to cancel gram. Kasi yung hinahanap natin is mole. Okay? So, the answer is, ilang mole ng ammonia? The 7.50 divided by 17 grams. Pero ma'am, bakit dyan? The answer should be 0.44 mole of ammonia. Ma'am, pero bakit dyan walang nakalagay? Guys, kasi dito, para maiwasan yung pag-round off, gaya nito, hindi lang yan 0.44, 0.44, 1176, and so on and so forth. Ang answer dapat dyan. Kasi guys, bawat, dito kasi sa mga stoichiometric problem, bawat decimal point is important. So, para maiwasan yung pag-convert, or pag-round off ng mga decimal point, dinediretso na yung equation. So, dito, gusto nyo na muna ipakita na kailangan mo na i-convert yung gram into mole of ammonia. Ito yon guys, oh. Ito yon, kinapi lang. But then, pwede pa nating idugsong yung kasunod. Ano yung kasunod natin i-convert? Hahanapin natin yung mole ni nitrogen. Kasi yung gram ni nitrogen, naintindihan nyo ba yung pattern? Ang given is 7.5 gram of ammonia. Ang hinahanap ay gram of nitrogen. So, ano yung pattern na gagawin? Gram of ammonia, kailangan ma-convert sa mole of ammonia. No? Bakit ma'am kailangan? Para ma-convert ito sa mole ni N2, ni nitrogen. Para yung mole ni nitrogen, mabilis na lang i-convert sa gram ni nitrogen. Naiintindihan yung pattern of solving. Kung paano pinapaikot-ikot at minamanipulate. Guys, please master your factor label method of computation. So, once nakita na, ito yun guys, so yung binox ko, ito yung nasa taas din. Similar lang yan. So, pwede na nating idugsong yung for every 2 moles daw. Kasi, ito may 2. For every 2 moles ni ammonia, merong ilang nitrogen. Ilang mole ni nitrogen? N2, sorry. Ilang mole ni N2? 1. Okay? Okay. So, for every 2NH3 daw, sa bawat 2NH3 daw na nagagawa, merong kinakailangan na 1 mole ni nitrogen. Naintindihan ba yon yung pag-compute doon? Kaya nabuo tong 2 mole ni NH3. Guys, by the way, before you proceed to something like the stoichiometry, you still have to balance your equation. Okay, so sunod-sunod yun. For every 2 moles of ammonia, kailangan ng 1 mole ng nitrogen according sa equation. So, dito, for every 2 mole of ammonia, kailangan ng, ma'am, bakit ammonia na naman yung nasa baba? Guys, kasi ito, okay, maguluhan. Ano na ika-cancel natin dyan? Yung 1 mole ng ammonia. Yung mole ng ammonia, kailangan maging mole ng nitrogen. So, we have to use this conversion. No? For every 2 mole of ammonia, no, kailangan ng 1 mole ni nitrogen. So, therefore, we can cancel mole of ammonia. Ang matitira na dyan ay mole ni nitrogen. Nakuha na ba yung tanong? Yung sagot? Hindi pa. Ano ba yung tanong? Grams of nitrogen. Nasaan step na tayo? Nandito pa lang tayo. So, dahil nahanap na yung mole ni nitrogen, guys, again, tulad ng ginawa dito, hindi na sinulat na 0.44112222. Guys, kasi importante bawat decimal. So, hindi pa tayo dyan tapos. Hindi pa kasi nakikita yung gram ni nitrogen. Okay, doon natin isosolve yun ng sabay-sabay dito sa next page. Okay? So, guys, tapos na tayo dito, no? Ito yung kanina. Nandito na tayo sa mole ni nitrogen. So, ano nang kailangan? So, yung kanina ha, gram ni NH3 yung given. Kinonvert natin sa mole ni NH3. Itong mole ni NH3, kinonvert natin through ratio dun sa equation to mole of N2. Iko-convert natin yan to grams of N2, which is the needed value. Okay? So, dito, ano na yung kailangan natin i-cancel? Mole ni N2, guys. N2. Ano ang molar mass ng N2? Ano yung molar mass? Ito ay ginagamit sa pag-convert kasi siya ay gram per mole. Dahil N2 yan, bawat isang nitrogen ay 14 grams. So, dahil dalawa yan, times 2, 28. Okay? So, ang molar mass ni N2 is 28, gram per mole. Uy, may grams ka na dyan. Grams per mole. No, ano na lang gagawin mo? Ilalagay mo lang siya sa equation. So, for every 1 mole of N2, yung ilalagay natin yung mole sa ilalim, meron tayong 28 grams of N2. Naiintindihan? Ito yung molar mass. Okay? Ito rin, molar mass. Ano to? Ito ay ratio of equation. Okay? So, ang total, ang sagot natin is 6.8 grams of N2. Tapos na ba? Tapos na. Okay? Diyan, guys, 7.50 times 1 times 1 times 28. 17 grams times 2 times 1. And then, i-divide natin. Okay? Para maiwasang magkaroon ng different decimal point. Kasi, pag ito lang muna yung kinompute natin, no? Pag ito lang muna yung kinompute natin, tapos, saka natin gagawin to at gagawin to, na-round off mo na yun nandito, hindi na yan 18. Naiintindihan? Every decimal point matter kay stoichiometry. So, please answer the following. Try to answer the following. You can pause this video before solving. Again, guys, before kayong mag-solve, hanapin nyo muna yung given. Kung maaaring maghanap ng molar mass, i-compute nyo na lahat ng molar mass para compute na lang ng compute. So, I will show the answer now. Kung hindi pa kayo tapos, kindly pause this video. Pakiki-compute ako. The best way to learn is to compute it by yourself. Okay? Hindi kayo matututo just by listening. You have to grab your pen, your paper, and solve it. Okay? So, the answer for this practice problem the answer for this practice problem is at the back of your Bettelheim book. I think merong mga, or nasa page siya mismo itong problem na to. Kindly check na lang for checking of your answers kasi nag-overtime na tayo. Next, we have limiting reagent. Guys, I'll send you a video about computation of our limiting reagent, ha? Okay, for percent yield, we have three types of yield now. Actual yield, theoretical yield, and percent yield. When we say actual yield, the mass of product formed in a chemical reaction recovered in the laboratory. When we say theoretical, the mass product that should form according to the stoichiometry. So, nagbe-base siya sa chemical equation. Okay, kaya siya theoretical lang. Yung actual, kung talaga ilobas sa laboratory. Yung percent yield, siya yung actual yield divided by theoretical yield. No, times 100. So, ito yung nangyari sa laboratory. Ito yung na-compute gamit yung stoichiometry times 100. Yun yung percent yield. Okay. Next topic natin is our heat of reaction. So, in almost all chemical reaction, heat is given, either given off or absorbed. Okay. So, for example, in combustion, oxidation yung tama, of carbon, liberates 94 kilocalorie per mole of carbon oxidized. So, carbon, solid, uling. Tama, pwede uling, carbon. Sinunog, expose sa oxygen or sa air, magpuproduce siya ng carbon dioxide plus yung na-emit niya, na heat. So, yun yung exothermic reaction. So, heat of reaction is the heat given off or absorbed in a chemical reaction. So, meron tayong exothermic, tinatawag at endothermic reaction. When we say exothermic, one that gives off heat. When we say endothermic, one that absorbs heat. So, heat of combustion is the heat given off in the combustion reaction. So, kung all combustion, kaya sinabi ko kanina, all combustion is exothermic because they give off heat. Diba? Kapag nagsunog ka ng uling, nagbibigay ng heat. Yun ay exothermic reaction. Okay? So, that's all for your chapter 4, chemical reaction. Please review and practice solving redox reaction and stoichiometry. At the end of this topic, no, sa inyong Bettelheim book, makakita kayo ng mga solving problem doon. And I think yung mga answer doon is at the back of your Bettelheim book. Also, I will send you some YouTube videos of other YouTuber na sobrang galing at sobrang bilis intindi. That's all, and we will be having our quiz this Friday, Saturday, Sunday, Monday. Thank you and bye-bye.